understand what is the need of this particular sailing. Then we will go into how this sailing is done. Now, we have seen great circle sailing. The biggest advantage of great circle sailing is the saving in distance. You can see here in the diagram, we have two locations, New York and Madrid. The green color track shows the rumb line track between them. And if you follow the rumb line track, the distance covered is 5940 miles. The red color track which you see is the great circle track, and there is a substantial saving in distance. The distance is reduced to 5770 nautical miles. So the biggest advantage of great circle sailing is that it gives us the shortest distance between any 2 points on the surface of Earth. Now, there is one disadvantage of the great circle sailing also. What is that disadvantage? In great circle sailing, it is possible that when you are following the great circle track, you may go to latitudes which are higher than the latitude of your departure and destination position. So the latitudes where you are going following the great circle track may be higher than the latitude of your departure or destination position. In a rumb line track, this never happens. In a rumb line track, you never go above the latitude of your departure or destination position. So this is a disadvantage which we have. Now the higher latitude have their own set of problems. You have restricted visibility, you have rough weather, sub-zero temperature, bad weather, high waves. So all these difficulties, and the biggest danger, the ice, glaciers or icebergs. So because of all these dangers and difficulties, we have to modify our great circle track. And this modified great circle track is what we call as composite track, and this is known as composite sailing. So obviously we want to follow the shortest distance between the 2 points, but it cannot be at the cost of safety. So you cannot put the vessel in danger. So what we do here is, in composite sailing, composite, the meaning of the word composite is basically the combination of two sailings. So what we do in this composite sailing is, we combine great circle sailing with parallel sailing. What is parallel sailing? Parallel sailing is basically sailing along the parallel of a latitude. So we combine these two sailings, great circle sailing and parallel sailing, and we get our composite track. So let's now see how do we obtain this composite track. So as I told you, composite sailing is a combination of GC and parallel sailing. That the track takes us to higher latitude, and higher latitude have their own set of problems which can put the vessel into danger. So we need to save the distance, but at the same time, we need to make sure that the vessel remains safe. So what we do here is, we combine two forms of sailings so that we get a saving in distance as well as we keep our vessel safe. So how do we do that? Now, first of all, we need to find out what is the latitude beyond which the ship is expected to face or experience dangers. So how do we find that latitude? It is known as the limiting latitude, and basically we have to limit our sailing to that particular latitude. We should not go northward of that latitude. So how do we identify or find that limiting latitude? There are basically three sources of information. So how do we find this limiting latitude? There are basically three sources of information which are available to us. One is the routing chart. Whichever area you are doing or your position is, you take the routing chart of that particular area for that particular month, and it gives you a very good idea what is the latitude beyond which you are likely to experience dangers. Dangers like ice, icebergs, sub-zero temperatures, restricted visibility, fog, heavy weather. So that is the first source of information. Second is you can get this information from the sailing direction. So they will also give you a good idea which is the latitude beyond which you should not go. And the third are the present weather report and weather forecast. So weather report and weather forecast, weather facts of that area will give you an idea what is the safe latitude up to which you can go. So we fix up our limiting latitude, and once the limiting latitude is fixed up, then we can plan our composite track. So how do we do that? Let's go into the whiteboard and let me show you how do we fix up our composite. Let us say we are in the northern hemisphere and we are going from position A to position B. This is our great circle track. Let's say this is the pole. Let's draw the meridian of A. This is the meridian of A, and this is the meridian of B. Now, when we are following the great circle track, we can see that we are proceeding to latitudes higher than the latitude of A and B. So we first fix up our limiting latitude. Once the limiting latitude is fixed up, then we can make our composite track. So let's say that we fixed up a limiting latitude. I will draw it here. So this red line which I have drawn, it represents our limiting latitude. We should not go beyond this latitude. There could be dangers. So the easiest possible method which comes to our mind is that we start from point A, move on the initial great circle track. As soon as we reach up to the limiting latitude, let's call this point as point C. Since you cannot go north of this particular latitude, you start moving on the limiting latitude itself. So from C, you do parallel sailing up to, let's call this point as point D. So you follow the parallel track up to point D, and from D, you follow the great circle track and come back to or reach your destination B. That seems to be the easiest possible method with which we can save something in our distance. The distance will be shorter as compared to a compared to a rumb line track between A and B, and at the same time we can prevent our ship from going into dangerous latitudes. So this is one option. Any other option coming in anybody's mind? इससे छोटा भी और कोई मेथड या और कोई ट्रैक हो सकता है
नया ग्रेट सर्कल ट्रैक बना देंगे जो जिसका पीक लिमिटिंग लैट होगा.
ओके, वेरी गुड. सो ये तो इजीएस्ट ऑप्शन हमारे माइंड में आया, बट देयर इज वन मोर ऑप्शन विच इज अवेलेबल टू अस, And in that option, we can reduce our distance further without crossing the limiting latitude. What is that option? Let me change the color now. Let's go to green color. What I do is, from point A, I do not follow the initial great circle track. I do not follow the blue track. I follow a new great circle track, a totally brand new great circle track. Which great circle I am following now? I am following such a great circle which passes from point A and it has its vertex on the limiting latitude. Let me draw that here. This is the track. So this green color track you see is passing from point A and has its vertex at the limiting latitude. It means after touching the limiting latitude, if you keep on following this green track, the green track is going to go like this. Okay, so this is such a track which passes from point A and reaches the limiting latitude at its vertex. So the point where it touches the limiting latitude, let's call it V1 or vertex 1. Okay, after this V1, I follow the parallel track, the red color track, and now I do not go up to point D. When I am leaving this parallel track to reach my destination, which is B, I follow another great circle track. Now that great circle track is passing from point B and has its vertex on the limiting latitude. So let me draw it here. We can change the color. We can pick up dark green. So from B, I draw a great circle track which has its vertex on the limiting latitude, this one. Now, if you proceed further, you see this great circle track also will start to move southwards. So this point where it touches the limiting latitude, let's call that point as V2. So what I follow is I go from A to V1. From V1, I follow the red color track up to V2, and from V2, I follow the dark green track up to position B. Now you can see this path which I have chosen. This path does not cross the limiting latitude at any time, so it fulfills our safety requirements. The second thing is that this path gives us a shorter distance as compared to the initial path which we were considering. How does it give us shorter distance? Let's see that. Now, if you are going from A to V1, using the previous path, the blue and red color path, we were first going from A to C and then C to V1. Now, A to C is a great circle track, C to V1 is a parallel track. Whereas, if you see the green color track, A to V1, alpha to vector 1, is a entirely great circle track. So we know that the great circle track gives us the shortest distance between any 2 points. So the shortest distance to be covered between alpha and vector 1 will be along the green color track. And if you follow the blue and the red track, the distance covered will be more. So we are saving some distance when we are going from alpha to vector 1. Similarly, Bravo to vector 2, if you follow the blue color track and the red color track, you will be covering more distance because Bravo to vector 2, the dark green track is the great circle track, and the great circle track gives us the shortest distance between any 2 points. So again, we will be saving some distance when we are proceeding from vector 2 to Bravo. Now, the path between V1 and V2 is exactly the same whether you follow the first option or the second option. So there is a saving in distance from alpha to vector 1, there is a saving in distance from Bravo to Victor 2, and at the same time, we have not crossed the limiting latitude also. So this is the method or technique which we follow to make a composite track between any two positions. Now, in the questions which we get in the exam, the limiting latitude is provided to us. We don't have to look at it from any publication. It is straight away given to us in the question. So we have to just pick up that information and plan our composite track. So I am erasing the blue color track now, and we are moving on to the actual track which we have seen. I'm erasing point C and point D also. So the composite track which we have now is Alpha to Victor 1, then Victor 1 to Victor 2, and Victor 2 to Bravo. Okay. Now this Victor 1 is the vertex of the light green great circle track. Similarly, Victor 2, V2, is the vertex of the dark green great circle track. So to calculate the composite distance, what I do is I join P with V1. So let's do that. Let me pick up blue color again. So we join Papa to Victor 1, and we also join Papa to Victor 2. Now, since V1 and V2 are both vertices, so that tells us that this angle here is going to be 90 degrees. Why this angle is 90 degrees? We know at the vertex, the great circle track moves in the east-west direction, and we know that the meridian moves or lies in the north-south direction, and they will intersect at right angles. So now we have three triangles in front of us. The first one is Papa Alpha Victor 1, PAV1. That is the first triangle. The second one is Papa Victor 1, Victor 2. This is the second triangle. And the third one is Papa Victor 2, Bravo. This is the third triangle. So these three triangles are there. We will be solving these three triangles and finding our answer. In a normal, simple composite sailing question, they give us both the position. They will give us the position of A, latitude and longitude. They will give us position of our destination, latitude and longitude, and they will give us the limiting latitude. This is the information which is provided to us. They want us to find out the total composite distance. Okay. So total composite distance between A and B, and they want us to find out the initial course and the final course. So this is what is required. Total composite distance, initial course, and the final force. So let us see how do we find these values. So first of all, let's go to triangle number 1, that is Papa Alpha Victor 1. Now, is this triangle a spherical triangle? Let's try to check. The first side is Papa Alpha. Now, Papa Alpha is the meridian of A. The second side is Papa Victor 1. Papa Victor 1 is the meridian of vertex 1 or V1. All the meridians are great circle. So ये दोनों की दोनों जो sides हैं, ये great circle tracks हैं. The third side, which is Alpha Victor 1, is again a great circle. We had made it as a great circle between Alpha to Victor 1. So Papa Alpha Victor 1, that is the triangle number 1, is a spherical triangle. So it is a special spherical triangle also because V1 angle is 90 degrees. So we can apply the Napier rule here. And Napier rule says that if you know any two things in this triangle, you can find out anything else. So let us see what do we know and what can we find. Number one thing which we know in this triangle is, let me pick up green color again, Papa alpha. Now what is this Papa alpha? Papa alpha is basically the co-lat of position A. Since latitude of A is given to us, the co-lat is also known. So this Papa alpha side is known to us. The second thing which we know in this triangle is Papa vector 1. What is Papa vector 1? Papa vector 1 is basically the co-lat of our limiting latitude. See, this vector 1 lies on our limiting latitude. This is given to us. So PV1 is the co-lat of our limiting latitude. This is also known to us. Now these two things known to us, we enter into the Napier's rule, and what do we do is, first of all, we find out side AV1. That is the first thing which we find out. Let me mention here as number 1. This is the first thing which we are finding, AV1. So we find out this AV1 and note it down. The second thing which we find is angle A. So again, you have to apply the Napier's rule and you can find angle A. So let me write it as number 2. Let me erase these triangle numbers. Now we again apply the Napier's rule and we find out the third thing in the same triangle. The third thing which we find is angle P. Let me write it as number 3. So this is the third item which we are finding. All three are found using the Napier's rule, and we have two things known to us in the triangle. So Napier rule can give us anything else. So 1, 2, and 3. These are the first three things which we find. Now I go to triangle Papa Bravo Victor 2. And in this triangle, again, you can see this is a spherical triangle. Papa Bravo is the meridian of B. Papa Victor 2 is the meridian of vertex 2. Both are great circles. And Bravo Victor 2 is obviously a great circle track. So a spherical triangle, and it has a 90-degree angle also. Vertex 2 V2 angle here is 90 degrees. So this is a special spherical triangle. And we again apply the Napier's rule. Two things which are known to us in this triangle are Papa Bravo side, which is the co-lat of our destination, and Papa Victor 2 side, which is the co-lat of our limiting latitude. So with these two, we enter into the Napier rule, and what do we find out? Three items we have already find out in first triangle. Number 4 item which we find is Bravo Victor 2, this side. So we find it and we just write it down. Next item which we find using the Napier's rule is angle Bravo. So let us write it as item number 5. And the next item which I find in the same triangle using the Napier rule is this angle P. So let me write it as number 6. So we just find all of these items and note them down. So now this triangle Papa Bravo Victor 2 is also solved. Now let's come to the middle triangle Papa Victor 1 Victor 2. Now in this middle triangle, if you look at it carefully, this is not a spherical triangle. Why it is not a spherical triangle? The side Victor 1 Victor 2, the red color side of this triangle which you are seeing, is not a great circle. Why is it not a great circle? Because you see this red color line which we have drawn here is our limiting latitude, and all parallels of latitude other than the equator are small circles. So this is a small circle. That's why Papa Victor 1 Victor 2 triangle is not a spherical triangle, and we cannot apply the Napier's rule here. So How do we solve this triangle? We have to find vector 1, vector 2 in this triangle. So how do we do that? Now, beta, you see, we have the longitude of A and longitude of B. If we find out the d long between them, difference of longitude between A and B, let me show that d long on the diagram. The d long between A and B would be this yellow color angle here. This yellow color angle which I have drawn at the pole is the d long between A and B. Now from this yellow color angle, if I subtract angle number 3 and angle number 6, अगर मैं एंगल 3 और एंगल 6 को इस येलो कलर के एंगल से सब्ट्रैक्ट कर देता हूं, तो मेरे पास ये रेड कलर का एंगल आ जाएगा, रेड कलर एंगल P. This red color angle is basically the angle P of the middle triangle Papa vector 1 vector 2. Okay. Now once I have this angle, I know this angle, red color angle, is the angle at the pole contained between the meridian of vertex 1 and the meridian of vertex 2. So this is basically the d long between vertex 1 and vertex 2. Now once you know this red angle, you know the d long between V1 and V2, you can easily calculate the V1, V2 distance. How do you do that? It is very simple. We use parallel sailing for this, and this distance between V1 and V2 is basically the departure. The east-west distance between 2 points on the same parallel of latitude is the departure between them, and we have the red color angle as their d long, and we know departure is equal to d long into cos of m lat. We have the parallel sailing formula, that is departure is equal to d long into cos of m lat. So d long is this red angle which we have calculated. M lat in our case will be the limiting latitude itself. Both the positions are at the same latitude. So we calculate this distance V1 and V2. This is the number 7 item which we have calculated. Now once you have all these items, just add up number 1, number 7 and number 4. When you add these 3 items, you get the total composite distance between A to B. And how do we find out our initial and final courses? Exactly using the same 1, 2, 3 method which we did in great circle sailing. So we have this number 2 angle available to us at A. We draw a rough diagram of the ship and follow 1, 2, 3. 1 is identify north, 2 is go clockwise, go up to the ship's head. And we know what is our true course at position A. The same thing is done at B. So you can draw a rough diagram of the ship at A. You can draw a rough diagram of the ship at B. And when you follow this 1, 2, 3 method, it will immediately give you your initial and final courses. So this is how we solve a composite sailing problem. So अब बेटा ये पूरा प्रोसीजर मैंने आपको एक्सप्लेन किया है. So जो भी डाउट्स आपके आ रहे हैं one by one, you can explain those doubts to me. So we will try to.
थोड़ा बहुत लंबा प्रोसीजर हो गया तो.
ओके बस बेटा 2 लाइन में शॉर्ट समरी आ गई. देखो कैसे हुआ. सबसे पहले तो ये ट्राइंगल आप समझ गए बेटा. अल्फा टू वेक्टर 1 इज ग्रेट सर्कल, वेक्टर 1 टू वेक्टर 2 इज ए पैरेलल ट्रैक, वेक्टर 2 टू ब्रेवो इज अगेन ए ग्रेट सर्कल. ये चीज तो आप समझ गए ना?
यस सर.
वेरी गुड. ट्राइंगल PAV1 स्फेरिकल ट्राइंगल है, पापा ब्रेवो वेक्टर 2 भी स्फेरिकल ट्राइंगल है. जो मिडिल ट्राइंगल है पापा वेक्टर 1 वेक्टर 2, दैट्स नॉट ए स्फेरिकल ट्राइंगल. तो यहाँ पे कोसाइन और नेपियर नहीं लगेगा जो मिडिल वाली ट्राइंगल है उसमें. सो अब हमने क्या किया बेटा, सबसे पहले हमें ये डायग्राम बनानी है. सो आफ्टर द डायग्राम इज मेड, यू एंटर इनटू द फर्स्ट ट्राइंगल पापा अल्फा वेक्टर 1. 2 चीजें पता है हमें, पापा अल्फा पोल एट ऑफ स्टार्टिंग पोजीशन, पापा वेक्टर 1 whole at of limiting latitude। इन दोनों के साथ नेपियर रूल में एंटर करेंगे और क्या ढूंढेंगे? पहली चीज ढूंढेंगे अल्फा वेक्टर 1 ग्रीन कलर साइड, दूसरी चीज ढूंढेंगे एंगल ए, और तीसरी चीज ढूंढेंगे दिस एंगल पी, दैट इज अल्फा पी वेक्टर 1 ए पी वी 1 एंगल। ये तीन चीजें आ गई। सिमिलर चीज करेंगे पापा विक्टर 2 ब्रेवो, ये वाली लास्ट थर्ड ट्राइंगल में नेपियर रूल के साथ एंटर करेंगे। दो चीजें हमें पता हैं, वन इज पापा ब्रेवो विच इज गोल एट ऑफ डेस्टिनेशन, सेकेंड इज पापा विक्टर 2 विच इज गोल एट ऑफ लिमिटिंग लैटिट्यूड। दोनों के साथ नेपियर रूल में एंटर किया और क्या क्या ढूंढा? सबसे पहले ढूंढा ब्रेवो विक्टर 2, उसके बाद नेक्स्ट आइटम हमने फाइंड आउट की एंगल बी एंगल ब्रेवो, दैट्स नंबर 5 आइटम, और नंबर 6 आइटम में हमने ढूंढा दिस स्मॉल एंगल पी, दैट इज ब्रेवो पापा विक्टर 2। ये नंबर 6 आइटम हमने फाइंड आउट कर ली। फिर इसके बाद हम मिडिल ट्राइंगल में आ गए। मिडिल ट्राइंगल में हमें V1 V2 डिस्टेंस चाहिए। सो ये हमने कैसे निकाला? इसके लिए हमने पैरेलल सेलिंग यूज की। पैरेलल सेलिंग का फॉर्मूला क्या होता है? वी हैव डिपार्चर इक्वल टू d long into cos of m lat। तो अगर हमें V1 और V2 में d long पता चल जाए तो हम ये डिपार्चर निकाल सकते हैं। डिपार्चर इज द ईस्ट वेस्ट डिस्टेंस बिटवीन टू पोजीशंस। So how to find the d long between V1 and V2? So for that we found out what is the d long between initial and final position A and B. This yellow color angle you see here at P, the big angle. This is the d long between A and B. This is known to us. We have the longitude of A and B available. So with that we can find out this big yellow angle. From this big yellow angle, if you subtract angle number 3 and angle number 6, you get the d long between vertex 1 and vertex 2. Put that d long in this formula. C long multiplied by cos of m lat. M lat is the limiting latitude, and you get the departure. Once the departure is there, you add alpha vector 1, vector 1, vector 2, and vector 2 to Bravo. Gives you the total composite distance, and angle 2 and angle 5 give you the initial and final courses. So again full method summarized now. So अब बताओ बेटा कहाँ पे डाउट आ रहा है?
Sir, all clear, no doubt. Thank you, sir.
Okay.
सर ये इसमें जो एमलेट है वो ए एंड बी के लॉन्जिट्यूड से क्यों नहीं करके निकाला सर?
ओके बेटा, एमलैट जब भी हम निकालते हैं, इफ यू वांट टू कैलकुलेट द डिस्टेंस बिटवीन टू पोजीशंस, तो एमलैट उन्हीं दोनों लैटिट्यूड्स का मीन होता है। अब यहाँ पे हम डिस्टेंस निकाल रहे हैं वर्टेक्स 1 और वर्टेक्स 2 में। हम लोग ए और बी में पैरेलल सेलिंग नहीं लगा रहे हैं, हम पैरेलल सेलिंग लगा रहे हैं वर्टेक्स 1 और वर्टेक्स 2 में। वर्टेक्स 1 और वर्टेक्स 2 दोनों का लैटिट्यूड लिमिटिंग लैटिट्यूड है, सो उनका मीन भी लिमिटिंग लैटिट्यूड ही होगा।
ओके सर।
ये और बताओ बेटा, और क्या डाउट आ रहा है?
सर ये V1 V2 डिपार्चर के इक्विवेलेंट हो जाएगा ना, तो टोटल डिस्टेंस A V1 V1 V2 और V2 B।
एग्जैक्टली बेटा, दैट्स राइट। V1 V2 इज कैलकुलेटेड एज डिपार्चर, तो जो भी ये डिपार्चर आएगा दैट इज द डिस्टेंस बिटवीन V1 एंड V2, और हमारा जो टोटल कॉम्पोजिट डिस्टेंस है वो है ग्रेट सर्कल ट्रैक फ्रॉम A टू V1, दैट इज द लाइट ग्रीन ट्रैक, देन departure which is the distance between V1 and V2, that is the red color track, और तीसरी लेग हमारे composite distance की जो है वो है Victor 2 to Bravo dark green color track which is again a great circle track। ये तीनों अलग अलग हमने निकाले हैं। लास्ट में हम इन तीनों को ऐड करेंगे, टोटल ऐड करने पे जो मिलेगा हमें that is the total composite distance between A and B। ओके, और बताओ बेटा, और क्या डाउट आ रहा है?
सर ये जो लिमिटिंग लैटिट्यूड जो हमारा बना हुआ है उसमें वो सेंटर वाला ट्रायंगल क्वाड्रेंटल ट्रायंगल क्यों नहीं हो सकता, क्योंकि अगर सेंटर मतलब 90 हो गया तो साइड।
ओके, तो व्हाट यू आर सेइंग इज कि ये वाला एंगल भी 90 है, ये वाला एंगल भी 90 है ना? सो व्हाई आर वी नॉट अप्लाइंग नेपियर रूल टू दिस ट्रायंगल, राइट?
वो सर ये जो हमारा लिमिटिंग लैटिट्यूड बना हुआ है वो साइड 90 लेके नहीं हो सकता सर, ये अगर हम मान ले कि ये साइड 90 है।
यू मीन टू से V1 V2 90 है?
यस सर।
पर बेटा ये तो जरूरी नहीं है ना कि ये 90 हो, ये तो 9 भी हो सकता है, ये तो 80 भी हो सकता है, ये तो 120 भी हो सकता है, ये कुछ भी हो सकता है। इट ऑल डिपेंड्स अपॉन कि हमें ए और बी दोनों पोजीशन का लॉन्जिट्यूड उन्होंने क्या दिया है, या दोनों पोजीशन कौन कौन सी हैं। ये तो कुछ भी हो सकता है, नॉट नेसेसरी इट विल बी 90।
ओके सर।
ओके, अगर वो बी पोजीशन को बोल दें कि बी पोजीशन यहाँ पे नहीं है और बी पोजीशन यहाँ पे है, ओके, और अगर मैं ये ग्रेट सर्कल ट्रैक बनाऊं तो आप देखो ये ग्रेट सर्कल ट्रैक यहाँ पे टच करेगा और V2 जो है वो यहाँ पे आ जाएगा। अब आप देखो ये छोटा हो गया ना, तो ये V1 V2 कितना बड़ा होगा, 90 होगा या उससे कम होगा या उससे ज़्यादा होगा, इट ऑल डिपेंड्स अपॉन द पोजीशन विच आर गिवन टू अस। सो इन पोजीशंस पे तो हमारा कोई कंट्रोल नहीं है, सो वी कैन नॉट से दैट V1 V2 विल ऑलवेज बी 90।
ठीक है सर।
ओके, और बताओ बेटा, और क्या माइंड में डाउट आ रहा है? ओके, क्लियर लग रहा है सारा?
यस सर।
एक सर वहां से डाउट था सर, वो जो आपने क्वेश्चन भेजे थे सर उसमें से डाउट था सर एक।
ओके, जो मैंने क्वेश्चन भेजे हुए हैं, ठीक है बेटा, ऐसा करते हैं, ये सेशन तो हमारा कंप्लीट हो गया, तो व्हाट यू कैन डू इज यू कैन जस्ट टेक ए स्क्रीनशॉट ऑफ दिस डायग्राम, so it will give you a recap of the full composite sailing and you can just save it with you। एक नेविगेशन का फोल्डर बना के उसमें आप ये सारी चीजें जो है वो स्टोर कर सकते हो। So this one single diagram which you are seeing on the screen right now will give you a complete overview of the composite sailing problem। So एक तो ये स्क्रीनशॉट आप अपने डिवाइस में सेव करके रख लो, एंड जो हमारे डाउट्स आएंगे अभी, वो सारे के सारे डाउट्स जो है वो नेक्स्ट सेशन में हम वन बाय वन सॉर्ट आउट करते चले जाएंगे। ओके, समवन हैज सेंट मी अ क्वेश्चन ऑन व्हाट्सएप आल्सो, मैं अभी उसे देख नहीं पाया, सो लेट मी सी दैट क्वेश्चन आल्सो। वी विल डिस्कस ऑल अवर डाउट्स इन द नेक्स्ट सेशन। तो अभी के लिए आप ये डायग्राम अपने माइंड में क्लियर कर लो, एंड एक चीज जो मैं अब आपको बताऊंगा इसमें वो ये कि दिस इज ए नॉर्मल कॉम्पोजिट सेलिंग क्वेश्चन विच कम्स इन अवर एग्जाम। हमारे पेपर में जो क्वेश्चन नंबर 4 है वो जीसी पे या कॉम्पोजिट पे ही आता है। तो कॉम्पोजिट सेलिंग पे अगर ये क्वेश्चन आएगा तो एग्जैक्टली जैसा आप देख रहे हो बिल्कुल ऐसा ही आएगा। तो ये 25 नंबर का सवाल होगा और इसे करने के लिए हमें 20 मिनट मिलेंगे, 20 मिनट। सो यू कैन सी नाउ हमें 7 आइटम्स निकालनी है यहाँ पे, और ये 20 मिनट या 21 मिनट आप ले सकते हो, 21 मिनट्स हमें मिलते हैं। तो एक नेपियर रूल की कैलकुलेशन के लिए कितना टाइम हमें मिला? वी गेट अबाउट 3 मिनट्स। ओके, अगर आप उसमें डायग्राम बनाने का या कैलकुलेशन करने का टाइम भी इंक्लूड कर लेते हो, ओके, अंडरस्टैंड करने का, क्वेश्चन अंडरस्टैंड करने का टाइम भी इंक्लूड कर लेते हो, तो यू गेट अबाउट 2 मिनट्स फॉर वन कैलकुलेशन। तो नेपियर रूल की कैलकुलेशन के लिए आपको 2 मिनट मिलते हैं। सो दैट्स द speed and accuracy which we require to pass in the exam। So अभी तो हमने इस कॉन्सेप्ट को समझा है, we are at the first step of the ladder। अब हमने इसके क्वेश्चंस को प्रैक्टिस करना है, और हमारी प्रैक्टिस इतनी पक्की होनी चाहिए कि हम 2 मिनट के अंदर अंदर एक नेपियर रूल को अप्लाई करते चले जाएं। So that's the efficiency, accuracy, what is required to clear the exam comfortably.